Hi guys, today we are going to answer questions related to the organic chemistry topic. Okay, so this is the question paper written February March 2018. Okay, now you have letters A to E in the table below that represents 6 organic compounds. Okay, now you need to study the table to check for the organic compounds, then answer the questions that follow. So now question 2.1, write down the letter that represents each of the following: a tertiary alcohol. Okay, so now when we talk about a tertiary alcohol, we talk about an alcohol, the carbon that is connected to the functional group must be connected to 3 other carbons. Okay, and the answer in this instance will be A, which is this one, because this carbon which has the functional group is connected to 3 other carbons, 1, 2, 3, and we call this a tertiary alcohol. So the answer here will be A. Then 2.1.2, give a letter that represents an aldehyde. So the letter that represents an aldehyde will be B. Remember, an aldehyde looks like a ketone with an exception that the functional group is at the end of the chain. So that will be B. Then a ketone. So a ketone, we are going to see it by the suffix of 1. So D will simply be the ketone. And a functional isomer of compound B. So a functional isomer of compound B. B is an aldehyde, and a functional isomer of an aldehyde is a ketone with the same chain length. So 1, 2, 3, 4, and this is butanol. So it has 4 carbons too. So D will be the answer to 2.1.4. So they want a functional isomer of compound B, which is D. Okay, now 2.2.1, write down the IUPAC name of compound B. Interesting, IUPAC name of compound B. Now regarding the aldehydes, you don't number the aldehydes. Why? Because the functional group is always at the end, so it will always be at position number 1. So this will be butanol. So the suffix will be Al for aldehydes. Okay, now the IUPAC name of compound E. Okay, now compound E, let's check the longest chain. Okay, here it's 1, 2, 3, 4, 5, 6, 7. Okay, from here it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we can count 8. So far it is the longest. Now if I'm counting from this side, it's 1, 2, 3, 4, 5, 6, 7, 8. So if I'm counting from right to the left, the first branch will be at carbon number 5. When I'm counting the other way around, the first branch will be at carbon number 3. So remember, we wanted the numbers of the branches to have the lowest possible numbers. So we're going to number from this carbon like this. Okay, so that will be the direction of numbering the longest chain, so that the branches can have the lowest number possible. Okay, now we have figured out that the longest chain is hex. I mean not hex but oct because of 8. So it is an alkane because of all single bonds. I'm not aware of any. Oh, forgive me, there's an OH here. There is an OH there. So because of that OH, the numbering will be affected. Now, numbering, we will consider the red one. Okay, initially I was gonna consider the blue one because I want, what do we call, I want the branches to have the lowest number possible. But now, since there is a functional group here, position 3 from the right, the numbering in red will take precedence. So we will have octane. Now at position number 3 we have an alcohol, so we need to specify that. Then OL, so it's octanol. Then at position number 5 we have ethyl, so it's going to be 5 dash ethyl. Then at position number 6 you have 2 methyls, the first methyl and the second methyl, so it will be dash 6,6 dash. So I'm going to wrap that one, 6,6 dash dimethyl. So octanol at position number 3. So this is the full name. At position number 5 we have an ethyl. At position 6 we have 2 methyl, so it's 6,6 dimethyl, and then octanol. At position number 3 is the functional group for alcohols. So under normal circumstances, and this was not an alcohol, the numbering would start from here at the blue side. But now, since the numbering prefers the functional group over a branch, so a functional group takes precedence over a branch, we now start numbering from the right hand side towards the left hand side. Okay, now you are asked a very simple question: define what is a positional isomer. So I'm going to move to the next page to define a positional isomer. So positional isomer can be seen as compounds with the same molecular formula but different positions. Different position. Now position of what? Position of maybe a chain or of a functional group. Functional group, the alkyl group, which is the branch, and what? A different position of the functional group, the alkyl group, on the parent chain or the main chain. So it is best that you know that if a positional isomer, it will be molecules of the same functional group. The difference is that the position of the functional group will be at different location. Okay, but they will fall within the same functional group. Okay, I hope that is loud and clear. Now write down the structural formula of a positional isomer of compound C. Structural formula of a positional isomer of compound C. Compound C is butanol. So compound C, it is butanol. Okay. So now we want a structural, a positional isomer of that. So butanol is like this: 1, 2, 3, 4, right? So this is the butanol that they gave us. At position 1, you have that, right? This is not the answer, eh? So at position 1, we have this. Now the positional isomer. Now positional isomer. Positional isomer of this will be what? We are going to move this to a new location. So it's 1, 2, 3, 4. Okay. Make sure that around every carbon you have 4 bonds. Now OH. Whether even if I could have moved it to this carbon that I'm busy with now, the OH will still be at position number 2, but numbering from the right hand side. So this is the only alternative. So this is another positional isomer to that one. So what changed is the position of the functional group. So now the position of the functional group is at carbon number 2. So they fall within the same functional group, but the position of the functional group, it is at a different carbon. We call this kind of molecules positional isomers. Okay. Now write down the structural formula of compound D. So we want the structural formula of compound D. Compound D is butane. At position 2, there's a functional group. So it is what we call a ketone with 4 carbons. 1, 2, 3, 4. It's a ketone, right? Now I want you to look at something. Now can you see they've numbered here, right? With ketones, as long as the carbons are 3, between 3 and 5, 3 or 4 or 5 carbons, your functional group will always be at position number 2. Okay, your functional group will always be at position number 2. So it's easier with ketones because it is always in the middle of the chain, never at the side. So it will always be at least position number 2 at the minimum. Now with 5 carbons, between 3 and 4, by the way, with 5 carbons, it's possible for it to be at position number 3 because there is a third carbon in the middle. So from 3 to 4, no need for you to be specific with the number because it will be obvious. Okay, now let us move. Compound D. Okay, I'm done with that. Now the organic acid that will react with compound C. So what is compound C? Compound C is an alcohol. Now they want you to write the structural formula of an organic acid that will react with this, and it must give you this molecule. So this molecule here that they are talking about is an ester. So an ester, it is made up of 2 parts. An alcohol plus the acid, which is the carboxylic acid. Okay, so this part here is the alcohol, then this is the acid. So now we need to draw an acid with 3 carbons. So we move from propanoid to propanoic. So what will it look like? So it will look like 1, 2, 3, then double bond O and O, then H. So the acid will look like this. And then this is the name, the structural formula of propanoic acid. Okay, so yes, this will be the end of this question. Now to challenge you, now attempt this particular question. It's similar to the one that we just did. Pause the video, look at it, and answer the questions that follow. Okay, so pause and answer. So this will be the lesson